today. Today we have Professor Claudio Calosi, who is, I would say, a very, very interesting philosopher. Although he is a young philosopher, he has already published like several papers in top venues. So it's an extremely prolific philosopher, actually one of the most prolific philosophers I currently know. So congratulations for that on that. His interests also are very fascinating. He works mainly in metaphysics of science, philosophical logic, philosophy of physics, and also recently started working in philosophy and literature. He is assistant professor at the University of Geneva in Switzerland, and also I think visiting professor at the University of Lugano, correct? Yes. He is the principal investigator for a huge research project on metaphysics on quantum objects. He has also published books, not just research papers. And today he will share with us his research work on Mariology, on metaphysics, let's say, on metaphysics. I know that the audience is not very well acquainted with this topic because in this department, we actually don't have, our department is not currently very strong in metaphysics, but knowing Claudio, I trust his ability to accompany us through this journey. Thank you very much, Claudio, for having accepted our invitation, and the floor is yours.
Okay, thank you so much. And Nevia, this was, me being prolific was your way to say I should get a life or something? So I'm just joking, of course. Anyway, thank you guys for having me, and thanks Nevia in particular, and Veronica, which is the first one that invited me, that she's not here, but still. So this is going to be a talk about, in general, it's going to be a talk about atomism. Now, I happen to think that atomism is one really of the crucial debates in the history of philosophy and beyond. As a matter of fact, before we start our formal journey, a metaphysical journey, I have actually prepared a few slides for you just to indicate how atomism, the discussion about atomism is widespread. It cuts across space. Wait, okay. So you see here me moving the thing, right? Okay, I'm guessing you do. So here's arguably the great, so from the east to west, so here is arguably the greatest poet to come out of modern day Afghanistan. Rumi, which has this beautiful poem, which is called the Poem of Atoms, of course. And this is really just an atomistic poem, right? And so, and of course, he has this beautiful, very famous line in the end, in which every atom, which is either happy or sad, becomes an emerald of the sun, of which nothing can be said, which is just magnificent, right? So from east, but also to west, here it's a shame that Veronica is not here, because I could have chosen so many things from Western culture, but I chose Flaubert, The Temptation of St. Anthony, because in the book, St. Anthony talks about atomism with a particular character, which is Buddha, as a matter of fact. I don't know why, I haven't figured out why, but this is a very peculiar book in Flaubert's oeuvre, let's say, because this is the first book he tried to write, and then he rewrote it for the rest of his life. And it's a very poetic book, and at a certain point, here is when the first discussion that he has on atomism with Buddha. And St. Anthony has this clear intuition that if he could penetrate at each atom, he could penetrate the secret of matter, and in fact, become matter, as a matter of fact. So it cuts across, space, it cuts across time. This is one of my favorite all-time quotations. This is the second book of the Rerum Natura by Lucretius. And this is not just atomism, this is a very radical view, according to which there's only atoms and laws of nature. So all you need to describe the entire universe are atoms and the way in which they combine. okay? And so this is, first century BC, and here is the last novel by David Markson, meaning is its last novel, which is also called the last novel. Now, I happen to think that David Markson wrote one of the most beautiful philosophical novel of last century, which is not this one. It's called Wittgenstein's Mistress, and it's, maybe you don't know it. I don't know whether you guys know David Markson. For example, in Italy, he's not very famous, but in the United States, he was one of the 5 writers that, for example, David Foster Wallace used to teach in his Forgotten Masters of English Literature. And Wittgenstein's Mistress is just an amazing novel. This is his last one. I would go as far as saying that it's as good as Wittgenstein's Mistress, but well, you should judge for yourself. So it cuts across time. This was published in 2007. It cuts across disciplines, of course. So on the left, you see Galton's original, atomistic revolution in chemistry. And then you see a recent book in philosophy on the history of atomism. But of course, given what, Nevia told us about my research profile, of course, I chose, probably the most iconic beginning of a physics textbook, which is Feynman's famous lecture on physics, in which he says, look, if we want to actually put in one sentence the most amount of information we can have about our world, what we discovered about the world, we should actually say just atomism. And you see it in blue. We should just say all things are made of atoms. If you understand what that means, you will understand the most amount of knowledge that we have gathered about our own world, okay? And of course, it also cuts across what we call sometimes the Great Divide, right? The Great Divide being continental versus analytic philosophy. So here is, in the analytic tradition, what we now refer as to, the Old Testament and the New Testament of mereology. This is Parts by Peter Simons, published in 1987. This is the new Cotnoid and Varzi. So they have both chapter about atomism, of course, but here is in the continental tradition, let's say, Hegel's science in the science of logic, actually arguing that atomism is not a physical doctrine in the Newtonian system, it's just a metaphysical one. This is just to say that, just before entering, right, I know that some of you will not be interested in some of the technical details at the end of the day, but I think we should all be interested in the broader debate about atomism, even if it happens that you're not interested in, some subtle technicalities, which I'm going to show with you. But I'm going to go slow because I know, as Nevia told me, like that you guys might not be familiar with even meteorology. So I'm going to go slow. I promise. So this is what we're going to do, but I'd rather spend more time on the contents rather than the structure, because the structure is fairly, straightforward, and I might take some time, just explaining the notions. Okay, so here's the thing, like atomism is roughly the claim that all things are made of atoms. This is exactly what Feynman says, okay? Let me put it this here, it's easier, okay. So here are 3 claims. First one is everything has atomic parts. The second one is everything is the sum of its atoms or a sum of its atoms. And the third one is everything is composed by its atomic parts. Now, on the face of it, they're clearly related, but they contain different notions, right? They contain the notion of part in the first one, being a mereological sum in the second, and being composition in the third. Now, you clearly get the feeling, even if you never did mereology, that they're related. But once again, on the face of it, they're really different notions at play here. Okay. So now this is what you usually find in some papers about this. A3 is to be intended as A2, and A2 is completely articulated in A1, which sometimes I don't understand what it means myself. So I'm going to give you a way of understanding it, which is fairly naive, but at least fairly precise. And here, there's a Salinger quote, just for you. Now, I am going to take it as follows, right? Does A1, the claim that everything has atomic parts, entails A2 and A3? That is, entail that everything is a sum of its atoms. That is to say, in a broader perspective, if I have to say what Feynman wants me to say, everything is made out of atoms, can I just say everything has an atomic part? And the standard answer to that question is yes, I can. I can't just say everything has an atomic part. I don't even have to say anything about composition or sum, and I would have just exhausted what atomism is. Anthony Shiver has recently argued that this characterization is defective. Intuitively, there are models that satisfy A1, but do not satisfy intuitively A2 and A3, by which I mean just simply that if you look at the world depicted by the model, A1 is true in that world, but the A2 and A3 are not. Okay, that's what he means. Now, Achille, which is, oh, by the way, Nevia, Achille says hi. I was chatting with him before coming here. Achille Barzi, which is one of the greatest meteorologists alive, not the greatest now, has defended the original characterization of atomism, both in a paper in 2007 and in the new book. Okay, so he says, no, I'm going to show you on the face of Shiver's counterexample, we will see what it is, that actually the traditional characterization can capture atomism. Okay, so I'm going to argue that Varzi is right, yet Shiver is not wrong. And that might strike you as like, how can you do that? Like, that's impossible, right? They're saying one saying A, the other is saying not A, right? How can they both be right? And apart from Lewis Carroll here, of course, that you see on the slides, I'm going to argue that whether A1 entails A2 and A3 depends on the notion of sum that you use. And if you use the notion of sum that are currently in the literature, I think just Achille is just right. I think there's a streamlined proof to the point that he's just right, A1 entails A2 and A3. Yet, there is a new notion of sum such that these might be more nuanced than it first seems. And in particular, I'm going to argue that there is a new notion of meteorological sum. We will go slow, I promise, such that it is not equivalent to ones in the literature. It helps reassessing the Shiver-Varzi debate. In particular, I will argue that A1 does not entail A2 and A3. And it's also important for different philosophical reasons that go beyond atomism. First of all, it helps us distinguishing meteorological structure and meteorologically unstructured holds just in pure meteorological terms, which is, if you knew a little bit about the metaphysics of components object, you would say, oh, that's kind of a, kind of a big deal. Are you sure you can deliver on that promise? And, I can deliver half away, let's say. And it can also be used to analyzing famous problematic cases in philosophical literature and in philosophy of science. As a matter of fact, I have one example, I think, from just classics in philosophy and one case from composition in special sciences. Okay, these, as we usually say, these are my, let's say, electoral promises. I think I can deliver on the letter of these promises, but I mean, there's something that goes beyond, right? The letter of the thing, that is the spirit of the thing. So for example, if you think that the meteorology I'm about to actually discuss with you can deliver a full account of structural objects, then I can't deliver on that promise. I think that it falls a little bit short of that, okay? Just to say that I'm fully aware that, it's not a complete account. I can't say, oh, finally I've solved one of philosophical problems, for example, of classical meteorology. That's not the case, unfortunately for me. Okay, good. So these are the formal frameworks which I'm going to use. Once again, I'm going to repeat it every time. Don't worry, I will explain it. The first, just look at the first two. The third one gets into play in the appendix where there's just formal results, but we will not even go over them. The first one is called minimal meteorology. Minimal meteorology is the meteorological theory that tells you only this, that partud, X is part of Y, is a partial order. That means that it's reflexive, everything is part of itself. It's antisymmetric. If X is part of Y and Y is part of X, then X equals Y, and it is transitive. If X is part of Y and Y is part of Z, then X is part of Z. And the other one is quasi-supplemented mereology that says, oh, take that and add another principle that says, if something has distinct proper parts, which we will see are parts that are not identical to the whole, then it has disjoint proper parts, which means it has proper parts that do not themselves share a part, okay? They're completely separated from one another, okay? So now, just to be thorough, because that's how I like to do things, this is just because I'm not really a good philosopher, so usually I do logic just because to hide the fact that sometimes my metaphysics is not as great. I shouldn't say that, but just, you know, to come out. So I'm going to use like standard first order logic, but a two-sorted logic. Sorted logics are the logics in which you have different domains of variables. In particular, I will have singular variables, which are lowercase letters, and plural variables, which are uppercase letters. The plural variable stands for a plurality of things. So for example, so if I want to refer to the philosophers in the room there, I should have, like, and I don't want to say the mereological fusion or the set, right? Well, I want to say really the plurality, I should have plural variables, right? I don't want to say Nevia, I don't want to say one philosopher in the room, and I don't want to say all of you. I want to say some philosophers in the room, for example, and I should have plural variables. Now, these don't look at it, it will never enter what we're going about to say. This is just to say that if some of you guys know plural logic, this is just orthodox plural logic. There's nothing unorthodox in the framework of plural logic that I'm using. And this expression is going to be read. X is one of the Y's. Let's say Nevia is suppose X is Nevia and A is a philosopher in Macau, philosophers in Macau, the plurality of philosophers in Macau. That just says that Nevia is one of the philosophers in Macau. Nothing more than this. It's just a very, very natural, has a very, very pretty natural and straightforward meaning. Okay, so I put the definitions for you because I didn't know how many people knew about that. So here's the two primitive notion that you have. I forgot one. One is that X is one of the Y's. The other one is B is part of A. This is primitive, and I told you how it behaves, right? This is how it behaves, like as a partial order plus the quasi-supplementation principle. Now I can define other notions. So here's one. B is a proper part of A, and as you can see, is just B is part of A and is distinct from A. So for example, my hand is a proper part of my body. Why? Because it is part of my body, right? But it's not identical to my body, right? And this just says, right, that when I use a plural variable on the left-hand side, it just says, so when I say, oh, the organs are part of me, I just mean all of them. That's what it says, okay? Same thing for proper part. So here's another thing that you need to keep in mind is the notion of overlap. So A overlaps B. This just means, if you read it, it just means that they share a part. So now, if you could see my house here in Switzerland, given the prices in Switzerland, it's very small. As a matter of fact, it's just 1.5 rooms. So for example, my kitchen where I am and my bedroom, they overlap, they share a wall, okay? They have a part in common, a wall. Okay. The contradictory of that is just that it's separated from, is the or disjoint sometimes you read in the mereological literature. So A is separated from B if it doesn't overlap B. So for example, my two hands are disjoint, right? They do not share any part. Of course, my hand and my body do overlap. Why? Because they share a part, because the hand is part of itself, right? And my body has its hand as part. So they share a part, namely my hand. As a matter of fact, they share many, for example, this finger, okay, which is part of both. It's part of both of my hand and my body. Okay. That's the same for plural variables here. It just, of course, given that it's the right-hand side instead of the left-hand side, as you can see here, there's an existential quantifier. So if A overlaps the axis, it means that it overlaps at least one. Okay, so for example, left hand of Nevia overlaps the philosophers in Macau. Why? Because it overlaps at least one philosopher in Macau. Okay. On the other hand, my left hand is disjoint from the philosophers in Macau, because my left hand doesn't share any parts with any philosophers in Macau. Good. And now we need a notion of being a composite object and being an atomic object. And this is just the classical thing of, that we've been done this for millennia, really. A composite object is just something that has proper parts, and an atomic object is something that is not composite, therefore there is nothing that doesn't have proper parts. Of course, I need to use proper parts, right? I can't say that it has no parts whatsoever, because everything is part of itself by reflexivity. So atoms really have only one part, themselves. They just don't have proper parts. They don't have parts that are distinct from themselves. That's what it means to be a mereological atom. Of course, that's not a chemist atom, right? Because a chemical atom might have parts. So everything now is complete. And now we start doing a little bit of formal work, but don't worry, I'm gonna go over all the definitions with you. So if you open any book of mereology, you will find 3 notions of sum, okay? So these are called sum 1, sum 2, and sum 3, just because sometimes philosophers have no imagination, or they're called by the name of those people that actually use them. So for example, sum 1 is also known as Goodmanian sum, because the great philosopher Nelson Goodman has it in one classic of analytic philosophy, The Structure of Appearance. So here's what it says. I'm going to read it with you, and I'm going to explain it to you. So it says A is the sum 1 of the x's if and only if, okay? This is just says A overlaps these shares apart with all and only things that share apart with the x's. That means to say A is the sum of the x's if it overlaps all and the same thing that the x's overlaps. That's it. That's all it says. It seems fancy, but it's just that. Okay. So here's sum 2, which is also called sometimes Lesniewski sum, because the Polish logician and mathematician Stanislaw Lesniewski had it when he first actually drafted basically the first instance of rigorous theories of parts and wholes, which is his mereology in 1916. It was just published in Polish, so basically no one read it. But he's credited for basically the first rigorous axiomatization of mereology, in particular what we call now classical mereology. And the notion of sum that he has is exactly this. It says the following thing. A is the sum of the x's. First conjunct says, well, if all the x's are part of A, and every part of A shares a part with at least one of the x's. So here's how, when I teach mereology, I like to think about it. The first one says, the first conjunct just says, oh, if A is the sum of x's, you should gather them all. If you want to take the sum of, for example, the philosophers in Macau, right, you shouldn't exclude Nevia, okay? Now, but that's not enough, right? Because, for example, consider the plurality that has, like, all of you guys and, this cup over here, or this book over here, right, about the wasteland. Now, this thing has all of philosophers of Macau as parts, right? But it has something more. So the second conjunct really just says minimize. No, all the parts of that thing should overlap at least one philosopher in Macau. And that's why this shouldn't count. The one that includes this shouldn't count as mereological sum of the philosophers in Macau. Why? Because this guy doesn't share any part with any philosophers in Macau. Okay. And finally, sum 3, it says, look, A is the sum of the x's if all the x's are part of A, which is the same conjunct that we saw before, and if A is included in everything that includes the x's. Okay, so that is to say, look, if you have something that includes all the x's, if you have something that includes all the philosophers in Macau, then you have something which also includes their mereological sum. Now, I don't know how versed you are in mathematics, and theories, for example, algebra. This is just, if you think about it, this is just the notion of least upper bound. Okay. For those of you, if you don't know anything about group theory, don't worry about this. Like it will not, I mean, it will play a little role, but we will never actually even use list upper bound. But just to say that if someone of you know, this is just the notion of list upper bound. And composition is just analyzed as follows. As you can see, it's just, it says this, the x's compose A, if and only if A is the sum of the x's, okay, and the sum we just defined, and this just says they are pairwise disjoint. So 2 by 2, they don't share any parts. Now, I don't know why we added this. I think it's just a sociological reason, because one of the most influential books in analytic metaphysics in the 90s, Material Beings of Van Inwagen, had this clause. So we still keep adding it. But I don't know whether it does any work. Of course, for you that know logic a little bit, technically speaking, this is just what we call a schema, right? You will have 3 notions of composition, depending whether you plug in here some 1, some 2, and some 3, okay? Good, so first now, the good thing about this is that even if you are not a good mathematician, and I am not at all a good mathematician, you can still already prove some interesting stuff, right? And when you prove stuff, it can't just, you jack up your endorphin accounts, like you feel better about yourself. So the first thing that you can prove is that if you actually restrict to a plurality of atoms, then composition and sum, you don't need to worry about this conjugate. They're just one, let's say, the converse of the other, so to speak. Why? Because if you take distinct atoms, right, they can't share parts, right? Why? Because they only have one part themselves and they are distinct. So given that we will restrict to that, this is just what we'll take. So if X is composed of A, if and only if A is the sum of the X's. And now once you have that, you can just straightforwardly translate the 3 propositions we started with. Now, these are nothing intelligent or clever about this. This is just really the mechanical translation of what I've been saying so far, okay? I'm just using the formal framework that I like best, but there's really nothing. This could be an exercise for your Logic 101 class. And given that we're not going through the proofs, okay, we're going to just see the propositions, right? So if you have any curiosities, of course, we can come back in the Q&A, but I will not go over it. Just believe me when I say that this is just a straightforward formal rendition of the 3 claims we started with. Now, here is the question, right? The big philosophical questions, apart from the technical details, that we have to address. Does having atomic parts capture atomism? And that is having atomic parts, which is called atomicity sometimes, strong enough to capture the atomistic worldview, according to which everything is a sum of its atoms, or everything is composed of its atoms. And now the good things about the formal frameworks, right? There's a limit to the formal work you can do. I don't think, for example, that you can formalize your philosophical problems away, right? It's not that just by doing formal work you solve the problems, but they help you, right, sharpen the question. For example, here it's one case in point. The sharpened question is, does A1 entail A2? Once I have the formal renditions of them, I can just check whether that's true, okay? So, and here is Anthony Shiver arguing that this is not the case. And I'm going to give you, so this is the original case, which is that it's used, it's made resorting to set theory, but there's no set theory whatsoever here. So don't worry about this. I'm just going to give you an informal presentation. So here's what we call, I mean, this is our name, infinite comb model, because it seems like a comb, and this goes on forever and forever and forever. You see my hand, right, moving on the screen, right, guys? Nadia, you see that, right? Yeah. Okay. Good. I didn't hear you, but I think you said yes. Okay. So here's what you have is the natural numbers. So this is 0, 1, 2, 3, blah blah blah. Here you have the singleton. That is the sets that contains only one number, 0, 1, 2, 3. And these you have the composite entities that have, these are the following set. These are the natural numbers minus this singleton that lies at the same height. Okay, what does that mean? This is the guy, this is the set which contains 1, 2, 3, 4, 6, 5, blah, blah, blah. This is the guy that contains 2, 3, 4, 6, blah, 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 and so on and so forth. There's nothing very clever about this either, okay? As you can see, there are two kinds of entities in this model, right? There are atomic entities here. They don't have any other proper parts. And there are composite parts here, okay? So here's one thing. The first one to note is that there are certain principles of mereology that will rule this model out. They will say, this is not an acceptable rule for part. For example, classical mereology, we will never see it, but has an axiom that says every plurality of entities has a sum. Now, if you look at this, there is nothing that corresponds, for example, to the sum of 1 and 2. Believe me when I say that. So if you think that classical mereology is the right theory of part2, this is not an allowed model. So you can just stop here and listen to, I don't know, the new Mika Pinson album or whatever. But if you don't think that, because a lot of people think that classical mereology is too strong a mereology, okay? And so this just says that the principle of restricted composition fails because, for example, there is no sum of 1, 2. The thought is that suppose you don't rule out this model, okay? Suppose you admit this model as, there are models of part2 that behave the following way. Now, Shiver thinks that in models like this, then A1 is true in, suppose you have a word make like this. Let me put it this way, for those of you who are not into model theory. Suppose there is a word like this. Shiver thinks that in this world, A1 is true, but A2 and A3 are not. And therefore, right, the standard characterization in this world fails. And that's bad. Okay, so here's his argument. Everything in the infinite comp model has atomic parts, and thus satisfy A1, okay? But every composite entity is composed by a further composite part, okay? Therefore, he thinks it fails to satisfy A2 and A3. So here's the thought. Everything has an atomic parts, right? If you go here, of course, for example, N has an atomic part, 0. As a matter of fact, it has also this as an atomic part. But all the composite parts of N have further composite parts. So you will actually go down these ad infinitum, let's say, and you will never bottom out at an atom, right? The atom will be here. They will never be along the shaft. Of course, this means, says Shiver, that this guy is not the sum of the atoms. It cannot be. Why? Because I can't just go on along here and I will always pick composite things. Okay. Therefore, he says, like in that world, in that model, right, A1 is satisfied, the A2 and A3 are not. Therefore, A1 is not strong enough to capture atomism. Okay, that's the main argument. Now, Achille took probably one afternoon to rebut the argument. Actually, I remember I was chatting with him when he was writing the paper, and he said, I have to go for 3 hours, and then he came up with the proof, because this is as good as he is. Like, it took me like ages to do the proof. So here's what Varzi proves in the paper, and then the same result is in the book. Provided that the notion of sum you use is one of the 3 we saw, then the infinite comp is indeed atomistic, no matter what your intuition says about it. In fact, it satisfies A3, and you can prove that A1 entails A3. And by proposition 1, given that proposition 1 says, well, composition is just the converse of sum, then you can also show that A1 satisfies A2. A1 entails A2, sorry guys. Now, as a matter of fact, Achille does it in a purely syntactical way. It just uses predicate calculus. I'm going to show you a streamlined proof, but I'm not going to go over it, right, with you. First of all, because it's not a proof that I did. I mean, I just streamlined it, but it's a proof due to Achille. So here's the proposition that you can prove. Infinite comp satisfies A3, okay? For example, if composition is understood as composition 2, that means like using the notion of sum 2, which is the Lesniewski notion. Now, as a matter of fact, Achille in the paper does it for all 3. I just happen to think that the proof is easier for composition 2 and sum 2. Now, I'm not going to show you this formal proof, but just to give you an idea of what we do when we do formal mereology, I'm going to give you a taste of how the proof is done. Okay, so how the proof is done, you pick a composite entity at random, say this guy, okay? Now you have to show, right, that there is a plurality of atoms such that this guy is the sum of that plurality of atoms. Here's how you do it. So you go here, you go down, okay? So from here, you go here, and now you take the infinite plurality, okay, of these atoms. Okay, that means that just the number 2, 3, 4, 5, 6, 7, 8, 9, and blah, blah, blah. Now you can go and check that this is a sum 2. Why? Well, all of these are parts of that, and all the parts of that, which are these guys and these guys, overlaps at least one of those, right? Because this part overlaps this part overlaps this part overlaps this, and so on and so forth. Okay. So this is how, technically speaking, you do the proof. But the thought is that no matter what your intuition says about that thing is a model of an atomistic mereology. That is, it's true that atomicity, as a matter of fact, A1 entails A3. In fact, A3 and A2 are both satisfied even without A1. So it's not true that A1 fails to entail them. As a matter of fact, they are true in that model. So this is the proposition that says that A1 implies A3, okay? So here's what Achille concludes, and rightly so, I want to add. And so let me pass to this line, because this is the same thing. It's exactly the same thing. I just actually took two propositions apart, which I will name Varzi 1 and Varzi 2. Varzi 1 just say, no matter how we understand the notion of sum, the thesis that everything has atomic parts turns out to imply that the thesis that everything is a sum of its atoms, which means just says, right, in this formal framework we've been using, the A1 entails A2. And insofar as being composed of coincides with being some of these joint entities, which is exactly the notion I've been using, the thesis that everything has atomic parts turns out to imply the thesis that everything is composed of atoms. Sorry about the typo. That is, A1 entails A3. Okay? So thought here is that all? Did Achille actually just drive the point home, and we should just talk about different things? For example, the literature has moved on and saying, oh, maybe we should define stronger notion of atomism, and then see whether Varzi's argument actually delivers also on those. Okay, I am going to take a different approach here. I'm going to ask, are the three notions of sum that you find in the literature the only ones that you can define in terms of, the two primitives, part of them being one of, or there are other ones? And here's how I'm going to do it. I'm going to lay down a few plausible desiderata of the notion of sum can be required to meet, okay? And then see that there's a notion of sum that meets them all, but it's not equivalent to the other ones in the literature. And then show the consequences for atomism. So here are the desiderata. Desiderata says, the first one says, well, if A is a sum of the x's, then the x's should be part of the sum. Okay. The other says, if A is the sum of the x's, what is separated from the x's should be separated from the sum. And the minimality says, what includes the x's should include the sum. So the first two says, look, so the sum should be inclusive enough, right? It should include everything you want to sum as a part. The second say, but not too inclusive, right? It's like having, an elite, let's say, dance club or something. Let's say you want to be inclusive, you want to have, as many people as possible, but if you want to be an elite club, you have to be a little bit exclusive. You cannot let everyone enter. And the third one just says, look, suppose I want to take the mereological sum of my t-shirts, okay, which actually is extensional equivalent, of course, of the sum of my black t-shirts. Suppose I put them all in a drawer, okay, then I have put the mereological sum of the t-shirts in a drawer as well. That's what it says. Okay. Why is this important? Because now I'm going to show you that none of the notions of sum we've seen so far satisfy them all. So, and here are the propositions that are important. In particular, the second part. So the second part says sum 1 doesn't satisfy the first. The 6.2 says sum 3 doesn't satisfy the second requirement. And proposition 7 says that sum 2 doesn't satisfy the third requirement. Of course, if you take them all together, it just says no notion of sum satisfy all three. Right? And I'm going to show it to you. So here are a few models. So these are called essay diagrams in which you have, so proper part to the relations go uphill along the line. That is, B1 is a proper part of X, X is a proper part of A1. Okay, now I'm going to argue that the first conjunct fails for someone. If I ask you, is X a sum 1 of A1 and A2? Unfortunately, even if A1 and A2 are not parts of A, right? X is part of them, but A1 is not part of X because of antisymmetry, right? Is X a sum of A1 and A2? Well, unfortunately, yes. Why? Because sum 1, remember, says X is the sum of A1 and A2 if it overlaps all and only the things that A1 and A2 overlaps. Is that true? Well, A1 and A2 overlaps 5 things, A1, A2, X, B1, and B2, and it just so happens that X overlaps them all. So sum 1 doesn't satisfy the first requirement, okay? So X can be a sum of things that are not even parts of it, which is bad, right, for someone. So here's the second case. This is, so you have A1 and A2, but you also have another thing, okay? So suppose that I ask you whether X is a sum of A1 and A2, even if it has another part. And unfortunately, the answer is yes. Why? Because remember, well, I'm going to say that to you, so that you don't have to remember. What the third says, it says like, look, A1 and A2 are part of X, check. And the second says, X is included in every plurality which contains A1 and A2. Well, there's only X, and X is part of X by reflexivity. But it shouldn't be, right? It shouldn't be, because X has another part, right? It contains too much to be the sum of A1 and A2. So that shows that X sum 3 fails. Okay, the second conjunct. It has actually something that is disjoint from A1 and A2, but it's not disjoint from X. Finally, okay, is X and Y here and A1 and A2, and I'm going to show you that X is a sum 2, okay, of A1 and A2, therefore failing the third conjunct. So is sum 2 says, well, A1 and A2 are part of X, and X overlaps, every part of X overlaps A1 and A2. And that's true, right? Because the part of X are A1 and A2, which overlaps themselves, and of course, X itself, which overlaps itself, because X is part of itself, okay? But is it included in every plurality that includes A1, A2? No, right? Because there's also Y. So, and X is not a part of Y, right? So this shows that X is a sum 2 and therefore fails the third requirement. You're going to say, why are you insisting on these 3? Because now, of course, what I can do, right, is just take the conjunction of all the 3 requirements, and I will have a new notion of sum. Then I'm going to be guaranteed that it is not equivalent to the other ones in the literature. Why? Because as I've just shown you, right, that in these cases, given that sum satisfies them all, of course, they're just the conjunction of them all, okay, cannot be equivalent to any of the sums, because at least the other notion fails at least one of the conjuncts. In particular, you can just go and check that X is never the sum of A1 and A2 here, is not the sum of A1 and A2 here, and it's not the sum of A1 and A2 here, as a matter of fact. In fact, if we were doing some formal work, I can show you that this notion of sum is stronger, logically stronger. That means that sum entails all the notions, but none of the notions entail sum, okay? So that's the thing that's just written here. Okay, good. Okay, I'm going to skip this, and if you want, we're going to go back. So the thought is Now that I have a notion of sum, a new notion of sum, I should reevaluate, you know, for example, I should ask what the notion of sum can do for me. And that's a very broad project that I'm exploring now. And I'm not going to do everything for you guys. I'm just going to do what are the consequences for atomism. In particular, I'm going to argue that now, even if Varzi was right when using sum 1, sum 2, and sum 3, is not right if we use sum. And instead of doing it in a vacuum, let's say, to actually do a little bit of history of philosophy and classical literature, I'm just going to do it with a particular case in the metaphysics, classic metaphysics. This is Metaphysics Z, in which Aristotle contrasts Eps-like objects, which is unstructured objects, which are nothing over and above their parts, they're just their parts combined, and syllables, okay, he says. It's just something more. As he says, you have A, you have B, and the syllable BA is something more than just A, B taken together, okay? And as he pointed out, it's not a heap, okay? So now here's what I'm gonna claim. I'm gonna claim that mereology I've just discussed with you can actually capture this. How do you do it? Here's how you could intend. Could. I don't think you should. I mean, you don't have to. And of course, I'm not even going to try to argue that you should, because I'm not an Aristotle scholar. So this is not exegesis of Aristotle in any shape or form, of course. So you start with A and B, then you do the sum of A and B, okay? The sum in the technical sense. And then you have the syllables A, B, and BA, which are not the sum of A plus B. As a matter of fact, you can show that AB is not the sum of AB. And I'm going to show it to you, of course. As a matter of fact, if I sent Nevia something which has the even more technical details of this framework, you can actually show that sums are unique. So you can show that there's a theorem that says that if X and Y are the sum of the X's, then X equals Y. Therefore, this is the only sum of A and B. There cannot be any other sum, as a matter of fact. So now, once you have this model, you can show all these beautiful things, okay? And here's what's important to us, okay? That A plus B is the sum of A and B. It's the only sum of A and B. But also you can show, right? And that's why, for example, it doesn't entail, so you can show that A1 doesn't entail A2. So go back here, right? It's not true anymore, right? That everything that has atomic parts is the sum of its atoms. Why? Take AB or BA, it's the same thing, okay? It has an atomic parts, I mean, provided A is an atom, of course. We can just assume it. Is AB the sum of its atoms? That is the sum of AB. I've just told you, it's not. And you can see why, right? I mean, if you cannot see it immediately, it's just because, you know, you've been exposed to it for the first time. But here's the argument. AB fails the third conjunct. The third conjunct says that if it is a sum, then it has to be included in everything that includes A and B. But it's not included in everything that includes A and B, right? It's not included in A plus B, for example, and it's not included in BA. So A plus B, on the other hand, it is included in everything that includes A and B. It is included in AB, it is included in BA, and it is included in this sum. Okay, so this is the only sum of those guys. So now the thought is that once you have this new notion of sum, like you can show that A1 does no longer entail A2. That is to say, I just undermined Varzi 1. I mean, if I didn't make any mistake in the proofs, of course. Okay. Now, of course, now you're going to say, wait a minute, that's just almost already establishes that A1 does no longer entail A3. And you would be completely correct, but I'm going to do a little bit more for you because, you know, you're giving me an hour of your time. So I'm thinking that I should do something more, which is, I think, of independent interest. And look at this, right? So look at this guy here. Now you can see the following thing. If you think about it a little bit. So you will have in this model 3 sum 2 of A and B. In particular, you will have a sum 2, which is A plus B, a sum 2, which is AB, and which are sum 2 that is BA. Okay. Now, of course, these are different things, right? So this is one sum that also satisfy the third conjunct of sum, and these are ones that do not satisfy it. Now, this says, there must be something about it, right? And I think this is helpful to just capture an important distinction, which goes way beyond the faith of atomism, which is the distinction between the distinction that Aristotle was actually interested in. And that's why I actually pick Aristotle rather than something else, and that passage in particular. The distinction between structured objects and unstructured objects, which are just the one, that are just identical, let's say, to their parts. I mean, they're just their parts. They have nothing over and above their parts. And I am going to do it by defining a notion which has been, a problematic notion once again for millennia. I would say the matter of a certain entity. And I will define that in terms of my new notion of sum. Okay. Now, to do that, I have to guarantee that particular sums exist. Now, in this particular paper, I don't want to commit myself to anything. So I'm just going to give you options. But in the paper that I sent to Nevia, for example, for different reasons, because I was interested in another debate, I had to actually take unrestricted sum. Now, these axioms here, I mean, we will not go over it. They're just written down in the order of logical strength. That is, all the downstream entailment holds, but none of the upstream entailments holds. The first one says, every plurality has a fusion. The second says, every plurality that has, technically speaking, an upper bound as a fusion. That is to say, maybe, okay, the fusion of me and Nevia, I mean, there is no fusion of me and Nevia because there is no such thing that has both me and Nevia as parts. But if you look at, for example, my two hands, okay, they have a fusion. Why? Because there is something of which both they are proper parts, my body, and therefore there also exists a fusion. And the third one is even more restricted. It says, the plurality of, not any plurality of my proper parts, but the plurality of my proper parts has a fusion. Now, it doesn't matter what you pick for the rest, okay? I'm going to pick this one just because it's easier to work with it, but it doesn't matter, as a matter of fact. So I'm just going to pick this one because it's easier to work with. I mean, and formally, it's just a little bit more elegant. But just rest assured that it doesn't matter in this case. Okay, so now what do I have? Well, remember what I told you, in particular, if I have this, but I can define what it's called a total function, but without this, I could just define a partial function. But given that sums are unique, I can define, technically speaking, what it is, a function. A function that goes from some proper parts to sums. And here's the function that I want to define. I'm going to define a function which I will call the matter of an entity. So let X be the plurality of proper parts of a certain entity. I'm going to say that the matter of that entity is the unique S, such that S is the sum in the technical sense of the X's, if there are such X's, okay, if A is not an atom, or A itself otherwise. Okay, that is to say, X is the matter of A when A either has proper parts. Okay, so my matter, let's say, or Nevia's matter, is the sum of my proper parts or her proper parts. Okay, but if you take a single atom, the matter of the atom is that atom. That's what the definition says. Okay, good. And now I am just going to define an unstructured. Remember what we're trying to capture, right? The intuition that we're trying to capture, that Aristotle was trying to capture, is that an unstructured object is just nothing over and above the sum of its parts. Okay, so I'm just going to say that an unstructured object is just identical to its matter. Okay. By contrast, a structured object is an object that is not identical to its matter. Okay. So in that case, if you go back, for example, here, you should see that the syllable is a structured object because it's not identical to its matter, because the matter of the syllable is the sum A plus B. That's the thought here. Okay. So all structured entities, let's say all entities that, are upward the chain of parenthood from the matter, okay, they will not be identical to its matter. Okay, as a matter of fact, this is nice because it also actually says that the method of a part, the method of an entity is just a very sui generis part of A. It is actually its unique maximal improper part, okay, which is that's to say that the part which is identical to the sum, okay, or it's the maximal proper part of it. The maximal proper part means that every other part is part of it, okay, which also means that it's also an unsupplemented part. What does it mean that it's an unsupplemented part? It means that every other part overlaps it, okay, shares a part with it. And it gives you also a thoroughly mereological relation between an entity and its matter, which is another feat of the account, right? Either the entity is its matter, or it is its unique maximal proper part. So I think that's how neat the formal system, I think, is. So why am I doing this? Because now, remember, we're going to actually talk about composition, right? We already did some. We need to do composition. I'm going to define composition in terms of matter. Okay. So I'm going to say that the X's compose A, if the first one doesn't matter for us, I mean, the pairwise disjoint, and the sum of the X's is just the matter of A. Okay. That's what this says. Okay. So as you can see, there's not the entity here. It's crucially so, it's its matter, which is composed here, which gets in the first argument place here. Okay, now, once you have that, you might think that, so here's one complaint that one has usually, according to this. Once you told me that, you're telling me that, there is no privileged decomposition, for example, of myself, right? So this notion is blind to some natural decomposition of me, for example, or Nevia into some particular plurality of proper parts of me. And you might think that that's bad because there are natural divisions. For example, here's a natural one, like my organs, my cells, and then go down to my atoms. But there is also a natural ones, for example, take, I don't know, 3 molecules in my left eye, and 4 atoms of my right lung, and then all the rest. That's it. There should be a way of capturing the differences in naturalness, let's say, in how natural these decompositions are. Now, what you can do is you can define a notion, I think you can define a notion of phi composition. In terms of composition, how do you do it? Well, you just say that the X's phi compose A. If they compose A, and by compose A you mean this, right? And they all satisfy phi. So what does it mean that a given plurality organically compose me? It just means that those parts compose me in this sense, right? And they all satisfy the predicate being an organ. They're all organs, okay? So if you take, I don't know, my right hand and my left eye, maybe that it's not a phi component. Why? Because it's not actually, as a matter of fact, an organ, I guess. Okay. And now, of course, in this particular case, we're interested in one particular notion of psi composition, which is atomic composition, in which you have the X's atomically compose A, if they compose A and everything, and they're atoms. Okay. Now, why? See, everyone can do this, not just people that had the mereology that I discussed with you guys. Everyone can do that now. But one thing is true, that it's the complaint that I started with, right? There are more natural divisions, and there are, let's say, less natural divisions. The thought is that if you think your mereology is going to reflect that, and you stick to some 1, some 2, and some 3, then your mereology will not be able to do the jobs. Why? Because there will still all be sums. There will all still be sums of atoms, okay? That doesn't mean that, if you augment, for example, your framework, you cannot capture this. For example, if you think that there are natural predicates, that corresponds to natural properties, for example, Lewis style, then, the natural division will be shouldered by your notion of naturalness. But it's not your mereology that we shoulder it, right? It's something else. Now, I'm going to show you that using a paradigmatic example taken from the special science, that I think this mereology can shoulder the thing in and on itself. Like, you will see that this natural division is just reflected in the mereology itself. So it doesn't have to go beyond the mereology to capture it. It doesn't have to go, for example, to naturalness or whatever to capture it. It's just let's say, enshrined in the mereology itself. And then I'm going to finish soon. Okay, so you start with the atoms, okay? You do the sum of the atoms, which is going to be the matter of the cells. Then you take the matter of the cells, you sum them up, you're going to be the matter of the organs. Then you sum them up, it's going to be the matter of the organism, and then you have the organism. And you can see that at every step in the natural division, it corresponds a particular passage from one unstructured object to a structured one, from a sum to something which is not a sum. And if you're familiar a little bit with mereology, you would see another very neat thing, that to each of these things corresponds a violation of a particular mereological axiom, which is called weak supplementation. But I never introduced it to you, so no. But the thought here is that this mereology is strong enough to actually capture the natural division and the hierarchical nature of composition, for example, if you want it to capture. For example, Achille doesn't want it to capture because he thinks that all this division in structure is just an epistemic constraint that we put in the world. The world, it doesn't come structured like this. It's just our epistemic practices that structure the world like this, but the world is not structured like this. So of course it doesn't have any problem. It doesn't need this mereology. And then once you have that, it's easy enough to say that for every structured entity, right, they will not be composed by its atoms. Why? Because their sum, it's not going to be their method. Okay. And once again, look at here, right? So this is a structured entity, but of course it's a structured entity. And the method of this, you can prove that it's A plus B. Okay. So it's not AB, given that AB is not the sum of A and B. It's not composed by A and B. Okay. And that just tells you that A1 does not entail A3. Okay. So I think I delivered on all the promises here. Now here's some more formal results you can prove if you just so wish. But I'll not go over it. Like, the thought here is that I'm going to leave you, because I already took an hour, I think. I'm going to leave you, instead of boring you further. The thought is that hopefully we'll learn more of how things can be composed, can be built out of these atoms. But I think that this incredible character here knew it all already, almost. This is Margaret Cavendish in Poems and Fancies. And this is one part of Poems and Fancies which is known as Atomistic Poems, which is a very dear book to me because Achille gave me as a present a beautiful copy of it. And Margaret Cavendish is an absolutely fascinating character. Like, I think there should be a philosophical play on her. Like, she was the first woman, for example, to attend and be inducted in the Royal Academy of London. She was a poet, she was a playwright, she was a philosopher. She actually engaged in discussions and almost actually got convinced that they were wrong. People like Hobbes, Descartes, and Boyle. She arguably probably was the first one to ever write science fiction novel. And apparently, I just read on Wikipedia that she had a beautiful sense of fashion, apparently. She dressed pretty well. And so I think that makes her just a fascinating character, really. And the atomistic poems are just so beautiful. And of course, they also gave the lecture, the title to this lecture, Small Atoms of Themselves, A World May Make. And if you read it, right, you could see that there's not just atomism, but there's also extended simples that atoms can have different shapes and different sizes, and they all fit together just to create the beautiful fabric of the world, which we see around us. And I cannot think of anything better than leave you with Margaret Cavendish. So there you go. Thank you for having me again.
Thank you, Claudio.
Should I stop sharing or not?
Thank you very much. Sorry, what are you saying?
Should I stop sharing now?
No. Yeah, no. Yes, maybe, so that we can see a larger you, yes. Thank you very much.
I can pull up the slides again. No, thank you guys.
Yeah, that was a very elegant and very complex, I'm sure, for the audience. Sorry. Perhaps a little bit, the audience may be a little bit unfamiliar with the Mariology, but you did a great job in trying to make things that are very difficult quite accessible. Thank you very much. I would like now to invite the audience to ask questions that may be also clarificatory questions, if there are things that you want to better understand, or
just let me say everything, so don't worry, there's a ask me whatever you want, and of course also like just big picture questions. I know that the formal details are a lot for you guys if you've never done Mariology, so don't worry about this. We can discuss general things.
Yes.
And also David Markson, if you want, I would be happy to discuss that.
Okay, so we now have a question from Saibai. You can also get that one. PhD student.
Professor.
Hi.
I have one question about the Aristotle syllable model.
Yes.
And the page after the that model, from 1 to 6 I could understand, but the 7 and the 8 I remember the plurality of something.
Okay.
Can you?
Yeah, sure.
Please, thank you.
Okay, so I'm just looking at it now. It just says so let me go to wait, let me share the screen again, just very briefly. Okay, this just says the following thing. Now this guy is the unique sum of these two guys. Okay, and that's just what it says, 8, and the other one says that any plurality which includes this guy but not this guy as a sum has this as a sum. Okay, so of course the thought is that, so because everything, right, so no matter how you define sum, everything is going to be the sum of itself. Okay, so you can just prove that sum is what we call idempotent. So if you sum, for example, Nevia with herself, you get Nevia. And that's important in Mariology because why it's important, because Lesniatsky was trying to really give, let's say, an alternative to set theory. And the problem that he had was a nominalistic concern. In set theory, if you start with me and you apply the so-called building relation to it, that is, you take my singleton, you generate new things. Because my singleton is not me, it's just another set. And the singleton of my singleton is another thing. And the singleton of the singleton of my singleton is another thing, and so on and so forth. And Lesniatsky has this nominalistic intuition that says, if you start from one thing, you cannot get more things for free, right? That's why in engineered Mariology in such a way that when you do it, notions of sum are idempotent. If you sum one thing with itself, just itself, you get only the same thing. So if you sum Nevia with itself, you just get Nevia. You don't get an infinity of things like if you do set theory. The same is true here. Therefore, AB, if you sum AB with itself, just itself, of course, you get AB. Now, if you sum it with BA, that is, if you now add to Nevia myself, then you get another thing, which is this. That just means that. It just means that our notion is idempotent. That just means that the same, of course, goes to BA. BA is the sum of itself. It's not the sum of A and B. That's the trick. That's the entire trick. Everything counts as the sum of itself, but it doesn't mean that everything counts as the sum of its proper parts. That's the trick that it does, but that's a very, keen observation, as a matter of fact. And the last one just says that this guy is the only sum of this, which I put because I wanted it to be a model of this guy here, of this guy. So if you have this principle, you have to, let's say, close it up here. You cannot leave it at that. But of course, if you don't think that there are, every fusion, for example, you're not a universalist, you might say, well, you give me A and you give me B, then you're going to have the matter of the syllable. And you can do with this matter, you can do two syllables, A, B, and BA. And then you might say, well, I don't know whether with these two syllables, I can make up another thing. You don't know, but I just wanted to be, on the safe side and just close it up for universalism. But that's what they mean. Was it satisfactory?
Yes, it is clear now. Thank you very much. Yeah.
You're welcome.
Yes, apologies. I missed the first 5 minutes of the talk, so you may have addressed this.
Well, the most beautiful ones. It's a shame. It's okay, don't worry.
So the first part of the question, how do you define proper parts?
So here's the definition of proper parts. So this is a definition. B is a proper part of A if B is a part of A, which is my primitive, and distinct from A. Now, so this is the standard definition, I would say, but there's a but. So I don't know whether you had this in mind, so I'm just going to say a few things because I don't know whether you had that in mind. Because if you had, that's a very keen observation once again. Like there's another notion of proper part in the literature, which is the following. B is a proper part of A, if and only if B is part of A, but A is not part of B, okay? Now you can prove that in the presence of antisymmetry, which I assumed, because I assumed that part of is a partial order, these two notions are equivalent. That means that they're extensional equivalent. Call it proper part 1 and proper part 2. That just means that I can prove the following by condition. X is a proper part 1 of Y, if and only if X is a proper part 2 of Y. And that's why I didn't distinguish between notions of proper part. If you give up antisymmetry, then these two notions come apart. For example, you can think that the statue and the clay it's made of, for example, are proper part of one another in one sense, but not in the other, okay? So for example, there will be proper part according to this definition if they're distinct, but there will not be proper part in the second one because there will be mutual part, okay? Is that what you had in mind when asking the question, or you would just...
That's it. That's very helpful. Thank you.
Yeah.
So the other part of the question, or perhaps it's a separate question. Again, it's quite fundamental, I think. So you say atoms have only one part. So my question is, how can it be a part if there's only one? What's it a part of?
Itself?
So what is the part a part of if there's only one?
So I think, so once again, like, so the snappy answer is itself. Why? Because it's just an axiom that part of is reflexive. Now, I think once again, I think you're touching on a very important issue here, which was discussed in the early days of mereology, which is when we use parts, usually we don't intend part. We usually intend proper part. So we don't go around and say, I'm part of myself. We go around saying, my hand is part of my body. But clearly, that's not just the improper part. That's not the reflexive notion. That's proper part. But I can prove, actually, given this definition, that proper partud is irreflexive. As a matter of fact, nothing is a proper part of itself. And why? This is because this notion here is irreflexive. Of course, nothing is distinct from itself. And once again, if you have that, then you're completely right in saying that if you have a proper part, then you have something else. That's exactly what this principle says. Wait, where is that? This one. If you have proper parts, then you have another one, at least another one. You're completely right. Now, the thought here is that you have two notions. This is just a matter of technical decision. Like, so if I think that there's a case to be made that when we use informally in conversation the notion of partud, it's really proper partud, and then you're completely right. There's always at least two of them. But this is guaranteed by this. Now, but when we are technical, it's up to me to define a notion of partud, right? That, you know, obeys the reflexivity axiom, and then therefore it's itself. And as a matter of fact, you can just show that you can take proper partud as primitive and then define partud like this. Let me see if I can pull. So you use this to define this, and now you do this. B is a part of A if B is a proper part of A, or this junction B is identical to A. Okay, that's if you use proper partud. And now you assume that this guy is irreflexive, and you can prove that this guy is reflexive. You can do both ways. Okay, so it just so happens that if you have the partial ordering axiom for partud, or equivalently, the strict ordering axioms for proper partud, which is irreflexivity, nothing is a proper part of itself. Asymmetry, which is stronger than antisymmetry, which is if X is a proper part of Y, Y is not a proper part of X. And then transitivity, if X is a proper part of Y and Y is a proper part of Z, X is a proper part of Z, then you get the same thing. You get that partud is a partial order and proper partud is the strict order, a strict partial order. And therefore atoms have only one part themselves, because everything is part of itself, even you. It's not just atoms, of course. Even me, you, that chair, Nevia, this beautiful book on the wasteland I'm reading, and so on and so forth. Everything is part of itself. Of course, this axiom says that these axioms is actually put exactly to ensure that if something is composite, that is, it has more than one part, then it has at least two proper parts. Okay, that's exactly the job of what they're called the quasi-supplementation principles. In general, the decomposition principles. Does that address a little bit?
Yeah, that was exactly it. Thank you.
Now a question from a student, an undergraduate student in physics.
Oh, wow. Hi.
Hello, thank you for
Hi.
the lecture. That's a good introduction. Actually, I got a question. Is this mereology is like from your introduction? It's like, to me, it feels more like a logics or metaphysical approach. And I'm wondering, what is the practical application of this mereology when it's come to understanding our worlds, like in physics? I'm quite curious.
Okay, good. So it started, as a matter of fact, sometimes, so I don't know how much logic you guys did, right? So sometimes when we do logic, we do first order logic, and then we do first order logic with identity, right? And we call it logic, right? But what we do is really, identity is not it's not a sentential operator, right? It doesn't actually bring together two propositions. It really brings together two things, right, in the world. The same here with partud. So you could call it first order logic with partud. Fine, I think you're completely right. At a certain point, this is just a formal theory. Now, as a matter of fact, I tend to think that this can be applied. As a matter of fact, this thing was applied to special sciences in which, for example, you have emergent properties. Now, if so for example, people tend to think sometimes that entanglement is an emergent property. And then if you have emergent properties, you have to say that there are some wholes that are more than the sum of its parts. And that's exactly what we will deliver. And as a matter of fact, if you're interested, I don't know what physics you do. So my project is on quantum mechanics. And for example, there is this guy, which is now in Singapore, which is called Isaac Wilhelm, which took, he was a mathematician, he took his BA, and physicist, which took his PhD, sorry, at Rutgers. He has an entire paper, which is called wave function mereology, in which he uses mereology and says, it's called projective partout. He says that, you know, one wave function is part of another wave function if it's just a projection, and he just proves, okay, that actually it obeys the axioms semi-standard classical mereology, and therefore he uses that to just actually, for example, do, let's say, divisions of Hilbert spaces in particular ways. So this thing, at the beginning, is just a formal thing. Of course, it's just a formal, it's just a formal apparatus. I think it should, as a matter of fact, be applied, and it has been applied. When I mean this, I don't mean this particular one that I presented. I mean just standard mereology. This one, the first paper of this one just got published just 2 days before, guys, I gave you the talk. So we didn't apply to anything yet. But the standard one with some, especially with some too, has been applied. So and if you're interested, there's a whole debate which is called quantum mereology. Of course.
But actually, for the proposition you propose in this PowerPoint, like the part, say atom, you add atom up and you get a cell, and you get organ, and you get organism, and say in your, say, in this mereology, this atom stuff doesn't change. It's just say A, B, C. It's stand for certain stuff. But in our reality, like in physical worlds, the atom stuff actually changes. Even say an electron becomes a positive electron. So this stuff changes. So how are you going to apply this law, like not a living law, to physics when actually physical worlds changes a lot?
So that's just, I think that's a genuine, a very important question, and I've been working on this independently. But this is an orthogonal question. This is not, if you think of it like composition, right? So this, let me put it this way. This shows you the limit of the mereological approach, right? I'm not saying that mereology can do everything. As a matter of fact, I didn't even tell you about the properties.
Right.
This thing doesn't tell you at all about the properties of atoms, of even composite objects. It doesn't tell you anything. As a matter of fact, it doesn't even tell you, and it shouldn't, as a matter of fact. I think it's important that it doesn't. That it shouldn't tell you, for example, that the sum of fires is a fire. For example, if you sum regions of space, that depends on the phi, right? If you sum regions of space-time, maybe you want to say you get regions of space-time, but if you sum cats, the sum of the cats is not a cat, right? Or the sum of the molecules of water is not a molecule of water. So that is to say that the mereology just gives you something. It doesn't give you the complete story at all. Okay. If you're asking your mereology to actually tells you about the properties, and therefore, for example, of change, then I think you're just asking too much of these things. Okay, I think, no. I mean, meaning it's a very good question, and but meaning the following thing, right? I think that we should use our formal thing, but we shouldn't expect too much. Like, I think that that's a question for physics, for example, right? To tell us, like, these things cannot answer all of your questions, because if it could, I mean, that would be great, because mereology is one of the few things I know, so I would have the answer to a lot of questions. But this is very limited. You can't just answer a few questions, unfortunately. And that's why I think you have to do philosophy of physics or metaphysics and so on and so forth. It will never tell you, this thing doesn't tell you, for example, even very simple things. Like if you want to say that the mereological sum of me and Nevia is located where me and Nevia are, this doesn't tell you that. As far as we know, with this thing I told you, it might very well be that the mereological sum of me and Nevia is in, I don't know, Sweden right now, which is crazy, right? Of course, but to do that, then you have to add things on top of that. You can't do it without Gibbs mereology. It's just not powerful enough.
Okay, thank you for your answers.
We have one or more.
Hello, Professor. Hello. Thank you
You
for
call
your
me Claudio.
presentation. I have two questions. Probably I'm not really completely understand. So please, the first question is I want to ask: are you not using the notion of atom different from the physics? Because you said that this is a metaphysical theory instead of physics. So can I understand the notion of atom you are using as the unit? The second question is, I'm thinking if you are saying that A, B is more than A plus B, so I have using a concrete example, probably my body is made up with my right hand and my left hand, and this is A and B. So and another way of making make up my body is my left hand is on my right side and my right hand is on my left side. So this is can I understand this type of two separate elements don't have a structure? So A plus B have more than because it cannot lack of the structure, so it cannot really, it have more than A plus B have more than AB, something like this. So I think is it the example I just mentioned is spatial differentiation. So if I say A plus B, AB is a combination, there's a different spatial structure, so probably there is many infinite possibility of combination. It can be temporal differentiation, something like this. So is it ambiguous to just say that A, B? So I need to clarify how they how they have the sum of the content. Thank you.
Okay, I see. Okay, so let me start from the first. Now, the notion of atoms. So this is a purely meteorological notion, right? It just says that an atom is, right, whatever doesn't have any proper parts. Now, if it just so happens that some of our physical atoms are atoms in that sense, the better for it, but who cares, right? So these are two different notions. As long as we're clear of what the notion we're using, then it's fine, right? For example, I don't know whether someone would say that an electron, which is an atom, right, has proper parts. In that case, it's also a meteorological atom. Of course, we also say sometimes an atom of hydrogen, for example, the hydrogen atom, that doesn't count, probably, as a meteorological atom. Why? Because probably has an electron and a proton as proper parts. So this is a purely meteorological notion, and we shouldn't confuse them. As a matter of fact, this picks it back to the etymology, right? What cannot be divided why cannot be divided? Well, because it doesn't really have parts. That's the notion I'm using, and crucially so, as a matter of fact. Now, for the other things, two things. At first, right, you shouldn't say that even my hand and my hand, my left hand, my right hand, and that's my body. It's even, my hand plus my left hand. That's not true. And my body has more parts. So you have to exhaust all the proper parts of the body in order to do that. Even if you do that, the meteorology tells you, for example, that Nevia might not just be just her body. Okay. Okay. So that's what the meteorology tells you. Now, if you're going to say, look, but is the meteorology able to capture, for example, properties, for example, spatial properties of the things? Then the answer is no. It's the same thing we were discussing before with the physics friend, right? No, I mean, the meteorology is completely silent on properties of the things. You can talk about spatial arrangement, can talk about temporal evolution, and so on and so forth. And that's a good thing. Why it's a good thing? It's a good thing because it makes us realize, right, that we cannot do everything we want to do with just one theory, with just one formal thing. Like our world is more complex than this. So we have to sit down, right? And now we have, so what if I bring in properties into the picture? And then we will have to see, maybe there are considerations from properties of things that will tell us something about the mereology. Here is one, which has been used in philosophy of physics. In philosophy of physics, it has been told, well, there are these particles, which so there's these quantum systems which are called the entangled systems, such that if you describe the whole, you describe the part. That's just a mathematical thing to say that if you give me the state of the whole, I can just give you, you know, the density matrices of the part, which is this mathematical object that completely describes the part, but the converse does not hold. Okay, the converse does not hold. That is to say that if I give you just the density matrices, the mathematical object that describes the parts, you cannot actually give me the description of the whole, because the description of the whole is compatible with different mathematical objects. Now, these considerations about properties of the parts and the wholes have been used to claim that in that case, if there is a sum of the entangled systems, it should be more than just the sum of its parts, right? But these are considerations that go well beyond what I just gave you guys, right? What I just gave you is just, so because I think one has to be also humble in what one can do, because I don't want to give the impression, oh, look at all these things that this new mereology can do. It can do a lot of things, but it's also very limited. Like, it has only two primitive notions. It has only the notions of part and only the notions of being one-off. It would be incredible if I could describe the entire world, how beautiful the Sistine Chapel is, right? So I was lucky enough to actually see once the Sistine Chapel, once there were just 3 people. Like, if I were able to describe the beauty of the Sistine Chapel just by using X is part of Y and X is one of Y, it would be incredible, right? So we have to actually, I think this is an exercise in humility, as a matter of fact. An exercise in humility in the following sense. It is true when you have formal things, you can do a lot of beautiful things, elegant things, and you can get carried away, but you shouldn't think that you can do it all. Right? I can't even say, suppose that, I don't know, my left half weighs, unfortunately, like, 50 kilograms, and my right half weighs 50 kilograms. How much do the sum of these things weigh? 100 kilograms, you'd say, but the mereology will not tell you that. You will have to do something else. The mereology will not tell you anything. It will just tell you that there is a sum. It will just tell you that there is this thing which overlaps both, and such that its parts overlaps at least one of these two things. It will not tell you what it is. It will not tell you how much it weighs. It will not tell you whether it's beautiful. It will not tell you whether it's boring. It will not tell you whether it's dressed in black. It will not tell you whether it thinks that Samuel Beckett is the greatest playwright, of the last century, and so on and so forth. I think, once again, that the lesson here is that, be rigorous, but be also humble. Like, just recognize the limit of what you're doing. The world might be way more than your formal theory just with these two notions can capture. And I made peace with that. Like, I'm sure. And we should do something else too, on top of this. And then we should look at interactions between the two. Right now, I'm looking, for example, at interactions between the notions of location and the notions of part, right? Or, for example, in the examples that you put, spatial relations. Right? So you can do mereogeometry. You can actually put another principle that says, for example, this region is congruent to this region, and see how far you can go. Now I'm thinking of another thing here. I'm thinking, for example, if I use the notion that Nevia is entirely located in that room, how far can I go? And now I have axioms that have the following form. On the left hand, they have mereological things, and on the right hand side, they also have locational things. That says, look, if all the parts of Nevia are in that room, okay, also Nevia is in that room. Okay. But of course, if I don't have another predicate for location, I cannot even tell you that. Okay. So much so for spatial arrangements, which cannot even be caught just with this locational predicate, as a matter of fact. it might very well be that to give a complete description of the world, we might need actually something which is a little bit richer than what I've been using so far. Yeah, it's just a message of humility once again.
Yes, thank you. That it was very fascinating also to include some meta-philosophical reflections to this final part of the Q&A. Thank you very much. That was very enriching for all of us. We now needed to say goodbye to you. Just goodbye. We hope to see you again.
I hope so too. And thank you for having me. And I know, guys, that this was too much. It was a lot for you. So thank you for having me.
No, it was very stimulating. And also from the questions, you see that you were very effective in your talk. Thank you. Thank you very much. Thank you and bye-bye. Bye.
Ciao, Nevia.